Hi, I'm George O'Connor. It's great to be in the Charles River campus again after 53 years after I arrived here as a college freshman. I'm going to talk a little bit about the lungs, which we haven't heard about today, but we studied lung health and pulmonary disease at the Framingham Heart Study. And in particular, I'm going to talk about chronic obstructive pulmonary disease. And just as a little background for some of you who may not be familiar with chronic obstructive pulmonary disease, it is considered have a global prevalence of about 8%. It's the sixth leading cause of death in the United States, and it's a leading cause of health expenditures and disability. We can define chronic obstructive pulmonary disease and ascertain its presence both physiologically by doing spirometry, for example, a test where you blow into a machine that measures your airflow and the total amount of air you can blow out. And we can see in a spirometry either normal airflow, as shown in the figure, or a slowing of the rate of expiratory airflow, an obstructive pattern of the pulmonary impairment. We can also assess the presence of COPD phenotypes by imaging, by CT scans in particular, looking both at emphysema, which is destruction of parenchymal lung tissue, and airway wall thickening, which can be associated with obstructive lung disease. In the Framingham Heart Study, we've performed spirometry at multiple examinations of the Gen 3 and offspring cohorts. We also did some in the original cohort. And we also have done CT scans at 2 time points that was mentioned. These earlier have done lung image analysis, both for emphysema and airway. So one thing we've done with these data, and we're using the whole genome sequence data from TopMed that Dan Levy mentioned earlier, is to develop a polygenic risk score for COPD. Now, the score is developed from the UK Biobank and Spirometry data, European data. We developed the polygenic risk score, then apply it to Framingham Heart Study participants as well as participants in the COPD gene study to see to what extent does a polygenic risk score help us to ascertain what a person's risk is of developing COPD. And as we've published, we can see that compared to clinical features like shortness of breath and smoking history, there's a significant additive effect of polygenic risk in ascertaining who has COPD. This potentially could have a role in case finding or spirometry in the future. We also got interested in the fact that there's an association between body mass index and COPD, obesity and body mass index. So, and this is work that my colleague Jingju Zhang, who was one of our fellows and now is a faculty member in our pulmonary section at BU, is leading, looking at a polygenic score for obesity and finding that that is, so actually, pardon me, I jumped ahead of myself. In this one, he's looking at the polygenic score for COPD and its relationship to the age of onset of COPD. And in both the COPD gene study and in the Framingham Heart Study, the higher the polygenic risk score for COPD, the earlier onset of the disease. And then finally, what I started to talk about, the relationship to body mass index. On the top graphic, we looked at the relationship of a polygenic score for obesity, for high BMI, to COPD-related phenotypes, emphysema, airway wall thickness. And in the top graphic, in Framingham, along with a number of other studies, a significant association. The higher the polygenic risk for BMI, the lower the lung attenuation, which goes along with emphysema. And finally, below, we wondered, getting a little bit at, well, how might this be related? BMI and obesity related to lung function. The lower graphic looks at intrathoracic adipose tissue versus pericardial adipose tissue. And what we see is if the intrathoracic adipose tissue is high and the pericardial adipose tissue is high, then there's an increased risk of developing, in this case, COPD, and the intrathoracic adipose tissue, which is including adipose tissue around the mediastinum and the airways, has a greater effect than the pericardial adipose tissue. So I'll stop there and just point out that we have ongoing research in the genetics and starting to get into the metabolomics and proteomics of airflow obstruction at COPD. Thank you.